The Energizer and your ground rod system are the cornerstones of a properly functioning electric fence. And in this video, we're going to go over some general rules to ensure that you choose an adequately sized Energizer and that you have the right number of ground rods installed. And that combination is going to ensure that your fence is functioning properly when the conditions are good, but also that it can respond to the challenges that are inevitably going to come along, like the faults that we show you in some of our other videos. When you're considering Energizer choices, the first thing you're going to be thinking about is whether your Energizer can be plugged into a power source or whether it needs to run on battery or be recharged by solar. A plug-in Energizer that can plug into your regular 110 wall power is going to be by far the most economical choice, and you're going to get the most power output per dollar. It's the best value for your dollar. If you need to run your fence in a remote location where you don't have access to power, you can choose a unit that's powered on a 12-volt battery, or you can choose an all-in-one unit that has a solar panel integrated directly into it. If you choose a battery-powered unit, you can take that battery back to your shop, recharge it, swap it with another battery, or you can install a solar panel along with that to charge that deep cycle battery up for a really robust and well-functioning remote system. However, I almost always recommend that people choose a plug-in Energizer, even if the power source is pretty far from the field, because oftentimes the additional cost of running insulated hookup wire out to your farm fence or building some additional fence to get you closer to your power source is a lot more economical than buying a large battery-powered or solar-powered Energizer. For a small Energizer around 0.5 joules, a solar Energizer might run around $400, a little bit over $400. A battery-powered Energizer of that size could be around $250, and for an equivalent-sized plug-in Energizer, you might only be looking at about $125. Then when you get into the larger Energizers, plug-in Energizers that are around 1 joule could be around $150 per joule. But if you go up in size, an 8 joule Energizer comes down to only $54 per joule. And some of the largest Energizers that Gallagher makes, the I-Series with a lot of features, including the remote controls we've showed you in some of our videos, those larger Energizers can be priced under $40 per joule. So you can see how the larger Energizers can actually be more economical even if the sticker price is higher, because you get more horsepower per dollar that you spend. So the joules is one of the primary methods that we're going to use to compare these different Energizers. A lot of manufacturers will show you right on the packaging the number of miles of fence that this Energizer could run, or the number of acres that you could fence with this Energizer. But that's not going to be apples to apples between the different manufacturers, because they're just choosing that number, and a lot of times that number is just a marketing claim. So don't rely too heavily on those acreage and miles of fence numbers. What you want to know is how many joules the Energizer outputs. So the joules is like the amount of power that the Energizer can put into the fence. And Energizers could range anywhere from 0.1 joule all the way up to 100 joules. It's a really huge range depending on what you're doing with the Energizer. Certain livestock need less power to control. Cows, horses, pets are going to be at the lower end of that. Once you get into animals like sheep that have a thick fleece, they're a little bit harder to shock, and you need more Energizer output for those species. Another thing that requires quite a bit larger Energizer would be if you're using any electric netting in the field, like poultry netting or sheep netting, but particularly poultry netting. There's a lot of wires on poultry net. It touches a lot of vegetation when it's set up, and it tends to draw a lot of power. So if you're using netting, either standalone with an Energizer or in conjunction with a permanent exterior electric fence, you really are going to want to increase the size of your Energizer quite a bit to make up for that. Gallagher's Energizers tend to have a pretty robust recommendations about the acres and the miles of fence that the Energizer can run. And what they have is they show you a comparison between what they call clean fence, which would be that sort of idealistic amount of acres you could run with it. That's going to be more comparable to what other manufacturers are showing you, but Gallagher will go a step further and show you under typical fence conditions how many miles of fence or how many acres could you expect to fence. So for example, on this small plug-in 0.3 joule Energizer, we're looking at potentially being able to fence 10 acres with this in ideal conditions. That would be one wire up in the air, nothing ever touches the fence. In reality, when you have multiple wires, vegetation touching the fence, shrubs growing into it, this is saying now we're talking maybe 3 acres of fence, or a half a mile instead of about 2 miles of wire. But in reality, this 0.3 joule Energizer also says that it could only really be used to control cows, horses, and pets. So if you've got other species, you're going to be looking larger, and even that 3 acre number or half mile of fence, when the conditions get bad, you've got wet ground, something hits your fence, that's going to completely stop this unit from functioning. It won't be able to send power down the fence, whereas a larger Energizer is still going to be able to power the fence in bad conditions. If we jump way up to this plug-in 11 joule Energizer, now they're saying that in a clean fence scenario, you could power a 650 acre farm with this. A typical fence, you're going to be down to 280 acres. However, an 11 joule Energizer is a size that I often would recommend even for farms that are less than 100 acres in size, depending on what they're doing. If you have a lot of subdivision fences, you're using netting in your field, you're going to be wanting to look at a larger Energizer. So if you take those recommendation numbers with a grain of salt, and it sort of starts you at your baseline, and then if you can go a couple Energizer sizes up from that, there's not going to be a big downside to that. You will never regret having too large of an Energizer. So as we mentioned, the Energizer's power is going to be measured in joules, and the joules rating that you're going to see on the Energizers is going to be the stored joules. That's the available energy in the capacitors that's available to discharge. So 11 stored joules. And a good rule of thumb could be for every mile of fence or every 1,600 meters of fence line that you have 1 joule on your Energizer. If you're fencing species like sheep, goats, then you might want to choose a 3 joule Energizer minimum even for a smaller property. Now when we talk about how many meters of fence, how many miles of fence, we're not talking about the perimeter of your farm, we're talking about the total distance, linear distance of wire, so of hot wires on your fence. So if you have a fence that's 1,600 meters long, but it has 4 wires on it, you're going to multiply that figure times 4 and just go around and add that all up. When we're talking about how much additional power netting fence needs, consider that a typical poultry net has 11 horizontal hot wires on it. And so for a given distance of netting fence, you actually have 11 times that much wire to account for when you're sizing your Energizer. And really importantly, those lower hot wires are down in the vegetation making contact. So the more shorts on your fence, the more leakage, the more vegetation touching it, the higher output Energizer you're going to need to select. The other side of the equation on your electric fence is your grounding system. And we have another video where we go in depth about choosing a location and the actual installation of your ground rods and connecting them up back to your fence or to your Energizer. But in this video, I wanted to talk about some general rules for ensuring you have an adequate sized grounding system, and then we're going to look at how to test that. So it is important that your ground rods are made of galvanized steel, ideally. It'll remain more conductive versus something like mild steel like rebar, which is going to corrode and reduce the conductivity and thus reduce the effectiveness of that grounding system. So definitely stick with galvanized steel and with hookup wire that's specifically made for electric fencing. For any permanent installation, I typically recommend at least 3 6-foot ground rods if it's going to be a permanent fence. But the actual general rule is that you probably want 3 feet of ground rod per joule of Energizer. So a 1 joule Energizer could be okay with just a 3-foot ground rod if it's a portable application like a solar energizer. You could get away with driving in a short ground rod like this one and pulling it out and moving it around. However, if you're doing that regularly, it is nice to just have certain locations where you drive one 6-foot ground rod longer down, you're gonna have a more effective ground. If it's a permanent application, then we really recommend starting with at least 3 6-foot ground rods. So 18 feet of ground rods. That would be acceptable for up to a 6-joule energizer. And then as you go up from there, just continue to add 3 feet of ground rod per joule, or 1 6-foot ground rod for every 2 additional joules. That's a good starting point. Now let's look at the fence in actual operation and how to test to determine if the energizer you have is adequately sized and if your ground rods are actually effective. We have a scenario to test out here so that we can show the functioning of an undersized energizer and then of an adequately sized energizer on this part of our fencing system. So right here we have a multi-strand high tensile fence with hot wires and ground wires. It's well constructed. There's no major faults or anything on the fence, and there's not much vegetation growing right now. The bottom wire is 12 inches above the ground, so there's not much vegetation coming in contact with this fence. It's pretty clean. The fence has a combination of sections that have 2 hot wires, 3 hot wires, or 4 hot wires, but when we add up the total distance of wire that we have, it's about 1,800 meters of wire. When we look at the specs for this Gallagher S10 solar energizer, it says it could be good in typical conditions for up to about 800 meters. So definitely undersized, even for a well-built, good quality fence. So we also have a good, adequate ground system with 4 6-foot ground rods right here that are spaced 3 meters apart each. So that's going to be functioning well. So when we've got our fence hooked up and we know that the conditions are good, we know there's no big faults on our fence, there's not a lot of vegetation, that's when we want to test our fence and make sure that your existing energizer or the new energizer that you chose according to those guidelines we discussed earlier is actually adequately sized for what you're using it for. So when I check the voltage on this fence, what I'm seeing with this S10 with good fence conditions is only 2.3 kilovolts. So with an adequately functioning energizer, we want to see the fence voltage above 5,000 volts in good conditions. And ideally, I'd like to see it even higher, up around 7,000, 8,000 volts. That's going to give you enough buffer and enough capacity that when something goes wrong, a branch falls on your fence or an animal breaks off an insulator and the wires are moving around, shorting out a little bit, you still have enough power on your fence to control your livestock, right? You don't want to find out that your fence isn't working because your livestock are all out on the highway. So clearly with this clean fence getting only 2.3 kilovolts, that's undersized. We can see that for sure. So now let's contrast that with the S100. The S10 is 0.1 joules of stored energy. The S100 has 1 joule. So that's what we're going to compare here. It's 10 times the stored joules available. So let's disconnect the S10 and we'll hook up our S100 to this fence. For the S100, Gallagher would recommend for a typical fence, multi-wire with some load of vegetation, this 1 joule energizer should be good for up to 13,000 meters of fence, and we only have 1,800 meters on this fence right now. So let's see how it does. Now when we test our fence, we're showing 5.4 kilovolts. So that's adequate for what we have out there right now, but it may not be high enough to add a lot of additional loads like poultry netting or to handle much in the way of faults on the fence under your normal operating conditions. So even though on paper this 1 joule unit is adequately sized for a real fencing application, like we talked about, you want to go up a couple of sizes if you can. You don't want to be right there at the margin. So let's hook some poultry netting onto this fence now, and then we'll see what that does to the performance. We've just got a typical 164-foot poultry net with 11 hot wires on it, and we'll connect that and test this again. So let's check that voltage with the poultry wire hooked up. So now we've just dropped down to 5,000 volts. So that only took us down about 400 volts, but it is only one net, and there's not much vegetation on there. The grass is really low because it's early spring here. So I would expect that if we saw the grass vegetation start to grow up into that fence, that could start to suck down this voltage even further. And I'm gonna go ahead and say that we're gonna be looking for a larger energizer, even for this relatively small setup of fencing, especially if we wanna add some netting. Okay, as I mentioned, this fence system has what I would consider an adequate ground rod system for a smaller permanent fence. It has 4 ground rods. They're each 6 feet or 2 meters long, and they're spaced about 10 feet or 3 meters apart, and they're connected with one continuous wire right back to the Energizer right here. So in order to test our grounding system, what we're gonna do is create an artificial short. We wanna be at least 100 meters away from the ground rods when we do this test, and we're gonna take something like, another galvanized ground rod, or something highly conductive, ideally, drive it into the ground and touch it to the hot wire on the fence. And we're trying to create a short that is enough of a short to suck the fence voltage all the way down to ideally 1 kilovolt, 1,000 volts. We want to see our voltage get right down low. And then we're going to test the last ground rod and see if it's able to collect back up all the electrons that are flowing through the earth back to the system. So if you need to, you can drive in more galvanized posts or lean up ladders against the hot wires, whatever you need to do to try to bring that voltage down. On a larger Energizer, it can really be hard to get that voltage down to 1,000, but if you have a well-performing Energizer, you can just put a heavy short on it, short it out as much as you can, then go do this test. So we've gone down and put in a galvanized ground rod, touched it to our hot wire. Let's see how we're doing. So now we've got our fence voltage down to 1.4 kilovolts, and we can see that current flowing down the fence toward the short. So now we're going to go down to our last ground rod and do our test. When testing the ground rods, we're trying to test the soil's conductivity back to the grounding system and the capacity of those ground rods to take back up all of the electrons that are flowing out through a big fault in the fence. That's telling us if the ground rods can gather all the electrons up immediately, then the animal is going to get the most effective shock. So when we're doing this test and we're shorting the wires to the soil, you want to make sure you're not going to just short your hot wire to your ground wire. That would create a dead short. It would be a highly effective short, but that current is going to flow down the hot wire, back to the ground wire, and right back to the Energizer effectively. That's going to bypass your ground rod system. So when you're creating that short, make sure you're shorting the hot wire directly to the soil until you get the fence voltage down below 1,000, ideally. We got our fence voltage down to 1.4, 1.5 kilovolts. That's going to be good enough for us for this test. So I'm going to put my ground probe in the ground over here. And this Gallagher fault finder has a great feature where you press this button and a little probe comes out. So that's really nice for testing something like a ground rod where it can be harder to get contact onto that plate. So now I'm measuring the voltage on my ground rod, and I can see I have around 0.5 to 0.6 kilovolts still reading on this ground rod. Okay, so the ideal for that number would be 0, but that's unrealistic. You're not going to ever have a grounding system that doesn't have any voltage on it with a big short, but we want this for sure to be under 500 volts, and under 300 volts is best when we have a short on the fence. This one's functioning right at maximum that I would want to see on there. There's around 500 volts on the ground rod. So what that tells you is if your voltage on the ground rod when you do this short test is above 500 volts, you need to add more ground rods to your system. In this case, we have a multi-wire fence that has a ground wire on it. your ground rods don't all have to be together. It's a good idea to have a good solid ground field right near your Energizer, you know, under the drip line of a roof back at the farmstead. But as you extend your fence throughout the farm, once you get about 1 kilometer away, you definitely want to add some more ground rods over there if you have a positive negative fence that has hot and ground wires on it. So in this case, when I see that I'm just a little bit short, when I get to a nice wet spot somewhere else on my fence, place with high soil moisture or near a spring or something ideally, or an irrigated pasture, I'm just going to add another ground rod over there and wire it up to my existing ground wires on the fence, and that's going to improve the grounding system of this fence sufficiently that it would be very well functioning. Now you've got some guidelines to choose an adequately sized Energizer and install the right number of ground rods to act as the foundation for a well-functioning electric fence system. And you've got the tools to test your existing system to make sure it is really functioning as it should be. Remember that the manufacturer's recommended acreage or mileage is largely marketing terms. You can run your own numbers and do your own test on your fence, and now you'll know if it's functioning the way it should be. And if you want to learn more about installing a grounding system or other techniques for building an excellent quality, permanent or temporary electric fence, check out some of our other videos.